Hello, we on? Good. Hey. Hello and welcome once again. I probably said it to you guys before, but I want to add my welcomes and thank you for attending RightScale Compute 2013. As you can see, my name is Brian Adler. I'm an architect in our services organization, and in that role I've had the opportunity to talk to a lot of customers and a lot of prospects about the applications that they intend to bring to the cloud, be they legacy applications or trying to find a way to make them work on the cloud, or they have some brand new ideas and brand new applications. And in that process, I've seen a lot of really cool applications. As my old boss used to say, the two guys in the garage with a credit card and a dream all the way up to the enterprise. So I've had an opportunity to talk to and see a lot of different use cases. What we've learned as we've gone through that is that a lot of times these are not set up from the best practices standpoint for outage proofing, dealing with high availability and disaster recovery in particular. And so that's what we're going to be here talking about today. I'm joined by Sanket Naik, who is the VP of Cloud Operations at Coupa, and he's going to spend a little bit of time talking to you about Coupa, about what they do, how they do it, and then at the end in particular about how they've designed for failure and high availability as well. So with that said, just a quick agenda before I hand it over to Sanket for a minute. As I said, you now know who I am and who Sanket is. Terminology and level setting. What I generally like to do when I do these talks is kind of lay out some terminology that I'm going to be using for the next hour. The intent there is not necessarily to say that these are industry correct definitions, but they're definitions that exist for the hour until you leave this room, essentially, just so we're all talking the same words for the same things. Okay? I'm going to have some takeaways, kind of things that I'm hoping you, the audience, is going to get out of this presentation. Talk a little bit about cloud and component definitions. Again, a little more definitions, but again, to kind of lay the groundwork on what is and what isn't meant by these different terms, and what is and is not available in the different clouds and the different cloud providers. Talk a little bit about designing for failure, about HA, how you can go ahead and set yourself up in a high availability configuration. We'll talk a little bit about architecture options and considerations. Basically, okay, how can I do this? How can I set myself up for HA in this particular region? How can I set myself up for a disaster recovery scenario if something really bad happens to the region that I'm currently deployed in? And then lastly, we'll have conclusions and Q&A. Sanket and I will be available for questions at the end and anything you have as we go through. We've got a fairly small group, which is great. So if you guys have questions as we go along, feel free to ask them. I can see you guys. Unlike the other room, I couldn't see anybody, so I can see if you raise your hand, so that'll be cool. And with that, let me hand it over to Sanket to talk a little bit about Coupa.
Thanks, Brian. Can you guys hear me? All right. So I just wanted to quickly start with talking about what Coupa is and what we do. So our mission is to deliver software innovation that breeds responsible spending while impacting the company bottom line. And what that means is, right now, spend happens at every company, and most companies don't have any processes. If you're buying stuff, you're doing it all on paper. And some companies have some software they have bought, they have deployed, but hey, it's a fact. Who likes doing expense reports? So the reality out there is a lot of companies have bought a lot of software for getting their spend under management. But they have failed. And so the founders of Coupa came together and realized that we need to really bring a refreshing Amazon.com experience to the enterprise world, so that people, there's some user adoption. People, employees most like to save money for their companies, right? They do, but given the right tools and software, if it's easy to use, they'll do it. Otherwise, they won't. And so that's what Coupa has done, is built a platform, built a solution where companies can get real spend under control. CFOs can realize real savings, and then they can take those savings and put them towards what their businesses are really there to do. Focus on their core business and not waste money. For example, we have had some customers where they have saved over $120,000 per year just on bottled water, just by changing who they bought the bottled water from. So those are real examples of our success. So as I said, spend happens whether it's pre-approved, post-approved, unapproved, and then we are providing a platform to do all of that. So that's what Coupa does. And this is our customer list, over 300 customers and growing. And again, if you look at this customer list, it's kind of I can imagine everyone in this room or your family has used services at one of our customers, whether that's buying clothing, or going out to eat, or listening music. You have probably used one of our customers. And then I was having an interesting conversation with someone, and we just had our first user conference a couple of weeks ago here in San Francisco, and I was talking to someone, and someone was saying, what does a procurement person's life look like? It must be pretty boring. And everyone was pretty surprised when I showed them this video that we shot at the conference.
Bring the action.
Rock it out, rock it now. If you know what we talking about, turn it up, burn down the house. Turn it up and don't turn it down. Here we go shake the ground. 'Cause everywhere that we go, we
Bring the action.
scream and shout and let it all out. And scream and shout and let it out. We saying oh, we oh, we oh, we oh. We saying oh, we oh, we oh, we oh. I wanna scream and shout and let it all out.
Yeah. So that tells you procurement is not boring. And I think the takeaway is that we can make customers dance. And I guess the second takeaway is that I need to do something about my awkward moves. So, anyway, back to Brian.
Thank you, Sanket. And I also want to give you guys full disclosure as well that myself and Miles Ward, if did anybody here attend Miles' discussion at 11:30? Okay, just so you know, you're going to see some repeats, okay? Miles and I did a webinar back in March that covered this topic, and we both borrowed some of each other's slides. So, like I said, full disclosure, if you haven't seen Miles's, then it's all going to be new, but if you have, just want to let you know. All right, terminology like I talked about. Fault tolerance, basically, as it says there, right, the ability of a system to continue operating when something bad happens, right? Something not catastrophic, but something bad, right? You might have a degradation of service, right? You might have usually had 30 millisecond latency for your customers, and now you've got 60 or 90 or whatever. But things continue to work when you lose a component of your architecture, right? Your high availability, or HA, that's why I call it HA. I always stumble on that one. So HA and DR we're going to be talking about. Your high availability, basically availability is your fault tolerant systems are measured in terms of their availability. And that's where you hear the nines, right? The 5 nines, the 3 nines, the 11 nines of durability that S3 has, and all that kind of crazy stuff, right? So that's what we mean by high availability, sort of that scorecard, if you will, of your fault tolerant system. And then DR, disaster recovery, as it says there. Basically, the process you have to get yourself back up and running as quickly and efficiently as you can when something catastrophic happens, right? When hurricane goes through and takes out, Northern Virginia, and you end out losing AWS USEs, for example, something along those lines, right? You haven't just lost a component, you've lost everything. How can you basically get yourself packed up, moved over somewhere else, and up and running in hopefully relatively short order with a particular RTO and RPO? Yeah?
Just a question, is DR usually factored into your HA or not?
You can. The question was, sorry, I assume you guys can all hear, right? But I should probably repeat it for the camera. So the question is DR usually factored into HA or not? And generally, I look at it as two very different things. I mean, they're what would you say? They're on the same tree but different branches or something like that. HA is really, and we'll talk a bit more about this when we get into some of these diagrams. But you'll see for cost, latency, security purposes, it makes sense to try to keep yourself in a single region and promote your availability within that region as best you can. And DR we look at more as, I lost this entire thing and I need to get myself set up. So you definitely should think about them at the same time, but there's some overlap in how they're implemented, and we'll talk about like multiple slaves and stuff like that. So you can think about them in similar ways, but they should be implemented slightly differently, and we'll show you some examples there, both in general terms as well as in RightScale dashboard terms as well. I'm going to talk a little bit here about RTO and RPO, so I've got them here, and you're probably familiar with those, but basically the RTO is your recovery time objective, right? How long does it take you to get back up and running when something really bad happened, right? That's sort of the short version of that. And the RPO, recovery point objective, is how much data is acceptable for me to lose, right? And these two are generally very much at odds, right? You can have a very aggressive RPO, your RTO might be very slow as a result, and vice versa, right? So the answer, I think Brian Goldfarb mentioned yesterday when he was in the panel, was saying, the answer in technology is always, it depends. It does. It depends on what your needs are and your requirements and all that kind of stuff. It's always a trade-off, right? And we'll talk a little bit more about those trade-offs in just a minute. Okay, so the takeaways we're hoping you guys will get out of this. Understand the core concepts around HA and DR. We'll talk about some of the architectural options that are available to you in not just AWS, but in the cloud in general in terms of promoting the high availability of your application. at how you can build these DR environments in physically separate, segregated geographical locations. Best practices for implementing these things, obviously with a bent towards the RightScale platform. We're at a RightScale conference here, so we'll kind of show you how we do it with our tools and within our platform. Talk about multi-AZ, multi-region, all that stuff. We'll get into that. And then lastly, understanding the tools that RightScale brings, RightScale bears, that facilitate this for you, or at least make it easier for you, right? And we'll talk a little bit about that at the end. I have some screenshots of the RightScale dash, and we'll talk about how you can go ahead and set up some of these configurations. Okay. First thing is a little bit more on nomenclature, and I talked about cloud components and definitions and stuff like that. Oh, this is really washed out, isn't it? Sorry. Regions and zones, right? So the concept of regions and zones. Those of you that are in AWS are probably familiar with this, right? But you have multiple regions, and within those regions, there are at least two. I think they all have three at this point, 3 or more availability zones, or zones as we're calling them here. The zones within a region share a LAN. So they have high bandwidth, they have low latency, and they have a private IP access, right? So if you're in US East 1A, US East period, servers in 1A can access servers in 1B and 1C, 1D, and 1E on the 10 dot, right? So that's all a private, low latency network. They also utilize, and this is the cloud providers give you that power, separate power resources, separate networking, redundant power, redundant cooling, all that kind of stuff to kind of silo those data centers, if you will. However, the regions, right, they're islands. They don't share any resources, and that's intentional, right? So if the entire region, US East, goes down for whatever reason, US West should be entirely unaffected, right? And that's done by intent. There are some huge pros about that, and there's some cons about that as well, and we'll talk a little bit about that. The cons primarily come into play when it comes time to do your DR scenario, right? You're on the public internet, and you have to deal with all the nuances thereof. Werner Vogels, the CTO of Amazon, has said this a while back, and it's sort of become very famous, and for a good reason, right? He says, everything fails all the time. And that's the way you need to think about it. You need to think that no matter what I've got here in the cloud, it's going to fail. And it can fail at any time. It can fail all the time. And I need to be prepared for that eventuality and work around that eventuality, right? Large-scale failures, they're rare, but they happen, right? And they've become a little bit more, at least, visible in the public recently, right? It's brought down some services that a lot of people rely on, like Netflix and stuff like that over Christmas, things like that, right? So they're rare, but they do happen. And ultimately, and this is an important point, is that in this sort of shared responsibility model that the cloud providers have, is that the application owners, you guys, are ultimately responsible for the HA and DR of your environment, right? They're giving you the tools. They're giving you a great set of tools, right? You open up this toolbox, there's a whole bunch of stuff in there, right? The analogy I always give is that, if you're a crappy carpenter, right, you're going to get blown down in the first big wind regardless of the great tool set you have. So you need to make sure that you yield those tools wisely that you have to build these HA and DR environments. You want to balance the cost and complexity, right? And that's the trade-off. It depends, right? When you do HA and DR, it's basically insurance, right? It's like buying car insurance or a home insurance or anything like that. How much am I willing to spend for something I hope that I never need, right? And that's really what you need to boil it down to. The nice aspect of all this is that the cloud infrastructure, the cloud providers have given us the tools that, in all of history, we have never been had this amazing set of tools, right? We can stand up multiple servers in multiple availability zones in multiple regions from our desktop in minutes, right? When else in history have been able to do that, right? So the ability to create these HA and DR environments is awesome, and you just have to think about how to do it and build it from, when you start to build your application, think about your HA and DR concerns from the ground up. Some basic concepts. Fault tolerance is the goal, right? No single points of failure. If something goes down, maybe I have a degradation of service, maybe my users notice a little lag or something like that, but overall, I'm still up and running, right? One thing going down didn't bring everything down. I need to have fault tolerance in all levels of my application. As we mentioned, avoid those single points of failure. And assume that everything's going to fail, right? Remember that mantra and plan accordingly, right? Every time you're taking a look at your architecture and every time you're taking a look at your application running in that architecture, think, that could fail. What do I do if that fails, right? Am I covered if that fails, right? And if I'm not, think about how you can set it up so that you are covered in that eventuality. This next one, very few people do, right? Plan in practice, right? It's one thing to have this HA configuration set up and your DR configuration in particular, and you might even have a plan, but you really should practice it, really, because when this fails, it's going to fail at 2, 3 in the morning on a Sunday. It's not going to fail at 10 a.m. on a Tuesday when you've had your coffee, right? You're going to be scrambling and get this done. So you want to make sure that you've gone through it once before, you know it all works, And you can do it when you're bleary-eyed hitting a button, right? And then lastly, right, remember that the better your HA and DR, the more money you're going to spend. Like we talked about, it's a trade-off, right? How much money am I willing to spend for this thing that I hope I never need to use, right? High availability. Don't sweat the small stuff, and it's all small stuff. In the HA thing, right, until something really bad happens, it's all kind of small stuff. So we'll talk a little bit about how you can handle this small stuff. The DR environment, maybe it's not quite such small stuff anymore. We'll talk about that as handling that in a little differently, okay? General HA best practices. You've heard this multiple times now about single points of failure, right? So if there's one takeaway I'd like you guys to get is no single points of failure. We recommend you always place at least one of each component of all the layers of your application in multiple availability zones, right? Load balancers, app servers, cache servers, database servers, whatever the tiers of your application are, right? If you got just one of them, unless it's a service that you can live without, it's something you should take a look at, okay? We recommend that you replicate data across availability zones for HA, right? You want to have yourself within this region and data's here and data's here. If I lose this, I still got this, right? And then you want to either replicate or back it up to another cloud or another region or whatever for that disaster recovery purpose, okay? And lastly, and I mentioned this in the talk I gave this morning about deployment checkups is, and I can't stress this one enough, setup monitoring, right? RightScale gives you a really cool, in my opinion, some people disagreed from this morning, but a really cool set of monitoring tools, right? And the ability to alert on those tools. And take advantage of those, right? Monitor your servers, put a bunch of alerts in place, right? They don't cost you anything. We're not charging you. You can have 100 alerts. We're not charging you for that, right? Put alerts in place to see when stuff's happening. You want to find problems when they're little before they become big, right? You want to be able to address them. If you can find them and solve them before your customer ever sees them or knows about them, that's a win-win, right? Okay, let's talk a little bit about multi-zone HA, and this is sort of a pictorial representation of what we've been talking about. This is showing just 2 AZs, but the concept, it's only to make the diagram a little easier to digest, but the concept is however many AZs you have, you should use the same basic concept. This example is showing US East. There's 1A on the left and 1B on the right. And you notice that we have multiple load balancers in different zones. We have an app server array auto-scaling across, et cetera, et cetera. You'll see that we have a slave database in a different zone, right? We're replicating from that master to that slave in that different zone to give us a little bit of failure isolation. One thing we should mention here as well, and I mentioned it in the deployment checkup one also, is that you pay for inter-AZ traffic, right? It's a penny a gigabyte. Generally, that's a cost people are willing to absorb, right? We really recommend spread yourself around those AZs, and if you're worried about pennies, then you're probably not really worried about HA, right? You probably have an app that can tolerate it or hopefully can tolerate it. You want to snapshot your data volumes, right? You want to snapshot those regularly and push those up to persistent storage, be it S3 or Cloud Files or Google Cloud Storage or whatever your persistent redundant storage is. Snapshot that data periodically, get it out of there, okay? You might want to consider local storage for additional slave databases. For those who are familiar with, how many folks here were in some way impacted by one of the AWS outages in the last 18 months or so? Right? A fair number of hands, right? Of those outages, virtually all of them were either EBS related or caused by EBS or at least were related to EBS, right? So what we recommend to our customers is, hey, if you can, and our general recommended best practice in AWS is to run your database server, your relational database server on EBS, right? But you're saying, hey, you know, EBS was causing all these problems. So what we tell some of our customers to do, if you really want to isolate yourself from those EBS backplane issues as well, you can run multiple slave servers using the RightScale Database Manager template. So you can have a master with EBS, a slave with EBS, and another slave that's running on ephemeral, right? Not dependent at all on the EBS backplane. If EBS goes down, you lose your master, you lose this slave's still up and running, right? You can promote this slave to master, use him until the EBS weirdness shakes itself out, and then go ahead and do your magic behind the scenes, launching new slaves, promoting the masters, get yourself back up and running on EBS, right? So again, think about what could fail, right? Again, okay, EBS could fail. How is that going to bite me? How can I work around that? All right, and again, that's more costs and a little more complexity, but again, that trade-off, right? How much are you willing to spend? And then lastly, Josep talked a little bit about this for anybody that was in yesterday afternoon session on how RightScale does its databases, right? We take advantage of Cassandra. So look at some NoSQL database solutions, right? Those kind of give you that built-in replication and sort of fault tolerance, and you can spread those across multiple AZs and multiple regions, right? We're running a multi-region Cassandra array. And you know, again, it costs a little bit more money, it's a little more complex, but again, you keep hearing that same theme, right? The trade-off. There we go. Now on to DR. All right, so again, this last slide here is sort of our pictorial representation. And again, as I mentioned, imagine there's 5 AZs here or whatever, right? The same concepts apply. Okay, disaster recovery. A couple new wrinkles, like we talked about, because regions are islands and share no resources, but the same basic concepts apply, and we'll talk a little bit about them. The HA and DR checklist. Determine who owns the architecture, DR process, and testing, right? Make sure that everybody knows who's supposed to do what, right? Make sure that that delineation of responsibilities is well understood, so when things happen at 3 a.m., you don't think Joe's going to do something and he thinks you're going to do it, right? You need to have these plans and processes well laid out so that you can really, like I said, do it bleary-eyed if you need to. You want to develop expertise in-house and or get outside help, right? You can, if you have folks that can do this kind of thing, that's wonderful. If you can't, there's a lot of companies, RightScale services, that could help you as well as others. So, you know, seriously, feel free to reach out to us, or we can help you guys with partners as well if you need some external expertise to get yourself up and running. Risk assessment. Look at all your apps, right? And like I said, look at each of your applications and the architecture you have built and say, if this fails, what do I do, right? If this fails, what do I do? And just repeat that process all the way up the stack or all the way down the stack, however you decide to do it. Specify your target RTO and RPO, and that's where you might need to work with your business units and your consumers and all that kind of stuff to figure out how long can I be down, what will you tolerate, and how much data are you going to tolerate that I can potentially lose. Obviously the goal is 0, but that may not always be possible, right? So specify that target RTO and RPO, and you need to plan your infrastructure around supporting those. And design for failure starting with the application architecture, right? Think about that application architecture, and that will help drive the infrastructure architecture, right? I had a customer a while back who had, you know, we had worked with them to lay out the greatest architecture ever. It turned out that they had a single threaded access to the database through one application server, right? Well, we had this beautiful architecture all laid out, but they had a single point of failure and a bottleneck for that matter, right? So they hadn't thought about the application architecture, right? You need to make sure your app can be highly available before you even think about putting it into a highly available infrastructure. So again, implement HA best practices, right? It's always a balance between cost, complexity, and risk, right? And I keep hearing that, right? How much am I willing to spend for something I hope doesn't happen? If something's super likely to happen, I probably should work around it regardless of the cost. If something is super unlikely to happen, it's going to cost me a heck of a lot of money, maybe I'm willing to tolerate that. So again, that's a decision that you need to make within your organization. Document those operational processes and the automations, right? Again, make sure that, you know, obviously we want you to plan them. Okay, good. The last 2 bullets points are to that point. Don't just plan, but practice it as well, right? Make sure that not only do you have it documented, but the document is correct and you can do it in a pinch, okay? You want to test it, and then for those of you who are familiar with the chaos monkey concept that Netflix had mentioned, try it, right? Make sure that you can do this, right? The chaos monkey is something that Netflix wrote that goes through and kills off servers and changes security groups and does all kinds of crazy things that you wouldn't normally do, but may happen in the real world, right? So whether you have a virtual chaos monkey or your own chaos monkey, right? Do whatever you need to do to make sure that these HA processes do what you think they're going to do. And you might just discover bottlenecks or things you hadn't thought of during those processes. Okay, talk a little bit about our DR options now. We'll talk a little bit about what we have our cold, warm, and hot DR, as well as our hybrid HA. And then Sanket will talk a little bit about how Coupa has designed for failure and how they've laid out their architecture and tried to mitigate all these things. Cold DR, that's by far the most common one, and the reason is that it's free, right? That's why people like the cold DR one. We'll talk a little bit about that. It's not recommended because it has a very long recovery time and potentially low recovery point, and we'll talk a little bit about those in just a minute. The warm DR is definitely the one that we recommend, and that's where you have, and we'll talk about that in a second, but that's where you have a slave database running in a different region replicating from your master, okay? So you have that data pseudo-live, at least close as you can, somewhere far, far away. The hot DR, we had a couple customers that were originally doing that, but no one does that anymore. It's way too expensive, and there's only a few use cases where it makes sense, and I'll talk about that when we get to it. And then lastly, the multi-cloud HA. We'll talk a little bit about what that means. It's really a live configuration, which brings to bear a whole bunch of other costs, security, latency complexities. Okay, multi-region cold DR. For those who are familiar with RightScale, most of you should be, and how the platform works and the server template concept. What we have, gosh, sorry, again, apologize for the washout, but I think you can understand it. What we have on the left is our operational setup, right? On the left we're running in, where's that, US East, right? So we're running in US East, we've got our load balancers, we've got our app servers, we've got our database. What's not shown here, but is implied, hopefully, is that this is spread across multiple AZs. Again, to simplify the diagram, I didn't show that, but we're following best practices within each of these bubbles. The way that cold works is that you now have a staged environment, right? For those who are familiar with RightScale, again, you can take those server templates and you can create basically a copy of that environment in a non-operational state in your other disaster recovery cloud. All those servers are staged, not costing you any money, but they're ready to be launched with the click of a button. The only problem is you got to get your data over there, right? So you got to get your data over there. So how do you do that, right? Up until recently, before you had the ability to do the moving storage from moving S3 objects, moving EBS snapshots from region to region, you had to do some funky tricks, right? You had to either launch servers in the other region and do rsyncs between EBS volumes and all this kind of stuff, right? Amazon has made it a little bit easier, but the point here is still that whatever that frequency that you ship data over, right? Maybe you ship it over every hour, maybe you ship it over every 4, right? If you're shipping it over every 4, you know this is going to fail at 3:59, right? You're going to lose almost 4 hours worth of data. Is that an acceptable RPO, right? If it's not, you can better think how you want to do this, okay? Again, the reason folks do this, basically free, right? You have to pay for the transfer charges as you're doing them and things like that, but there aren't any servers running. This is what we see and what we recommend, and as far as a hybrid environment, we've talked a lot this week about hybrid configurations. Folks that have a private environment and they want to have a disaster recovery, generally they'll use this with the public cloud being their disaster recovery environment. What we see here is US East and US West, but the concepts are the same between Rackspace, Amazon, Google, your private cloud, whatever it may be, right? So in this configuration, what you have is you have the same thing on the left. You've got your environment up and running, doing its thing. And on the right, you've got one server running, okay? Hopefully that's shown by the dark blue there. That slave database is in that other region, and it's replicating live from your master in your primary region. So we call it warm because not all the servers are shut off. You have that one server that's up and running. And the only thing you're paying for is that server and its associated storage and the bandwidth out as you ship that data across, all right? This adds some complexity, right? Because we're egressing on the public internet at this point. There's a whole nother, actually we're not doing it this time. There's a whole other presentation where I go in a lot more detail on this. Anybody that'll be in, was it Tuesday, Ryan? Tuesday. Anybody that's going to be in the San Francisco area next week, the AWS Summit at Moscone or whatever, Ryan and I will be doing a discussion and a demo of basically talking about this hybrid model and the pitfalls around it. So I won't get into the gory details here, but the point being is that you're now egressing on the public internet. So you have to worry about latency, you have to worry about cost, you have to worry about security. So I'm going to give a little plug for one of our partners who's not here today, but there's a company called CloudOpt, and the product is called Cloud Optimizer, and it basically allows you to do a lot of things, but one of the things it allows you to do is point-to-point encryption. So basically you can go ahead and give the slave database that's in, what is that, US West? The slave database in US West, the IP address of the master in US East and vice versa, and it intercepts traffic at the IP tables level and encrypts it and compresses, well actually it WAN optimizes, it's more than compression, and ships it across. So that sort of takes care of that security and latency as best as it can. The cost is still something you have to worry about. But the point being is that this is an implementable solution, right? This is not an intractable problem, okay? So like I said, this is by far what we see the most of our customers, what we recommend, and what we see most of our customers in a hybrid environment doing something like this. And lastly, excuse me, is the multi-region DR. Excuse me. And as you see here, same concept as warm, except everything's running, but I'm not sending traffic to both sides. I'm only sending traffic to one side. And you know, the reason we don't recommend this is expensive, right? You're paying for all this stuff running that you're not sending any traffic to whatsoever. The only reason folks use this is it allows a much quicker RTO. You can get yourself back up and running. The one customer we originally saw doing this, and they've since ditched it and gone a different way, is they were a window shop, and they had a lot of these servers took a long time to boot. They had a lot of configuration going on and things like that. So they wanted to have them operational because the amount of time it took to boot exceeded the RTO that they had promised to their customers. So they've ended up doing a slightly different thing. But like I said, we did see this. We don't see anybody doing this anymore, and it's definitely not recommended. Warm is far superior to this, a lot cheaper, and it only has a slightly longer RTO. And then lastly, we're going to talk about hybrid HA. And this is a live configuration. And this is where you've got, on the left, you've got US East, and on the right, in this one, it's OpenStack running in CloudStack or wherever, running in a different environment. Basically 2 separate clouds. You've got everything operational. You're sending traffic to both sides, but you've only got one master database, right? And that one master database in this example is in US East. So the problem being is that every single load balancer connection to the app servers, now you can change that so that they only send to their local ones and whatnot. But any connection from the app servers to the database in the other region, you have to worry about securing that and the latency and all that other kind of stuff. If this is a user-facing application, the folks that are hitting the right side of the diagram are going to see much more latency to their responses or to the requests than the folks on the left side, and that's generally not going to be acceptable. It's also very expensive. You're paying for all this bandwidth, and you got to figure out how to secure an auto-scaling array, so you've got to use a VPN overlay and all this other kind of stuff. So we don't see many folks doing this. We did have a customer that did this for a social game launch, and once things had calmed down a little bit, they swapped it out because it turned out their bandwidth bill was a lot higher than they had anticipated. And one more comment, and I'm kind of going to beat some of those same points to death right here, but it looks similar to multi-zone, right? If you were to kind of say US East 1A and US East 1B over there, it would kind of be the same thing, right? But it has those additional problems. You need DNS management. You need some sort of geo IP thing to send folks that are closest to this, hopefully geographically closest to this side, and the folks that are closer to the other side, Machine images are specific to a particular region, right? RightScale solves that for you. We'll talk about that with the MCIs. Granted, Amazon has recently introduced the ability to move their AMIs around, but until very recently, that wasn't even possible. We talked about security, right? This is now on the public internet, and you got to figure out how to do that. And it's in an auto-scaling environment with servers coming and going. Probably got to use a VPN overlay, right? You really can't use any sort of point-to-point because you don't know the points. And with that, I'm going to hand it over to Sanket to talk a little bit about how they've designed for failure and how they set up their environment.
Thanks, Brian. So one of the things while I was listening to Brian, I realized is that if you have one takeaway from this talk, and maybe some of you guys haven't been taking notes, but you guys are going to make the slides available, right? Yes, yeah. So when you get a chance, when the slides are available, go back through every one of Brian's bullet points and make that a checklist. Because it's absolutely necessary, and some of those things we have learned the hard way, is absolutely necessary to do all of those things if you really want to run a rock solid enterprise on the cloud, and that's coming from someone who runs his entire business on the cloud. We run our entire business on the cloud. So one of the things I wanted to go back to that that Brian mentioned was designing for failure, and so. An area where a lot of companies fail is they have this software or app running on premise, and they think they can just throw it on the cloud, and it's going to be a cloud app, and that's not true. So in order to architect for the app, you need to change your mindset a little, and build the app to be truly cloud ready, to use all the mechanisms that you have on the cloud and really use them, and be ready to. For the components of the application, the components of the infrastructure to fail more frequently than they would on your on-premise infrastructure, and be able to handle that, be resilient to that. And be resilient to that, and be able to recover gracefully from that. So you just have to, when you're designing your applications, you need to keep that in mind. The second thing is when you're looking at some of these things and trying to figure out what's the right fit for my company, which DR model should I go to? And the way I would look at it is the first one is your service level agreement. Whether it's to your internal customers, if it's an internal app, if it's to your business units, you're running an internal application, maybe you don't need the availability or low RTO, or you have a different recovery point objective. On the other hand, if you're running your business on it, you have customers paying for it, a SLA violation results in thousands of dollars of credits being issued, then you need to think of it from a different perspective. Then your cost of not delivering that SLA justifies the additional cost of building out a DR. So think of your service level agreement. The second thing to look at is where you are as a company. And when I say company, it might mean your organization. If you're part of a larger company, where you are and pretty much what stage you are at. So maybe if you're just starting out, you're putting this application on the internet, and you might just start out with just having everything in one region, and then as you grow and you see the you see the drivers to add more and more DR. That's when you start adding the additional pieces for disaster recovery. But it always helps to start out thinking where you're going to be. So I had this graphic here of Superstorm Sandy, and this was one of the drivers for some of the things that we did on our infrastructure from a disaster recovery perspective. So just before I get into the details of this, to give you some insight into what we do. So Coupa is a software as a service, cloud-based service, and the technology stack is Ruby on Rails, and we use MySQL as our database, and we use S3 for storing all the non-transactional pieces. So it's a really relational, really transactional system. We run real financial transactions through the system, and so one of the primary service goals from my perspective is ensuring zero data loss. And so I cannot afford to lose data because transactions cannot be replayed. So that's one of the primary goals even before HA, to make sure that no transactions are lost. And so what we do there is we run MySQL in a master slave configuration in one region, and we have additional database, a slave database that runs in a second region that's completely in sync with the master. And I think Brian mentioned one of the partners, and we do use them. We use Cloud Optimizer for three things. One is to make that secure tunnel between the two regions. The second is to make sure that the slave is in sync with the master, because if it's not in sync with the master, we're going to lose data. And the third thing is that the data is compressed, so that we are not paying high data transfer costs to Amazon. So that's the setup we have for zero data loss. Then the next thing is our service level agreement is 99.9%. We have done several months where we have 100% of uptime. There are some months where we have 99.9%, 99% of uptime. And does anyone in the room know how much downtime that is? 99.9%, 99% of uptime. That's 4.32 minutes of downtime in a month. So that's very important. And if you're in IT and you need to have conversation with a business person, I think that's an important number to know. What does 99.9% of uptime translate to in terms of minutes, and what 99 point? Because there's an exponential degree of cost and complexity to going to the next 9, and how it translates into minutes. And in some cases, you might look at it and say, going from 4.32 minutes to under 1 minute just doesn't justify the cost. So that's an important thing to know. Again, just something I wanted to highlight. We are running enterprise software on the cloud, and it's a financial transaction system. And the way we have tried to build out a service is to build it out as a true cloud solution. Make the assumptions while building out the solution, while deploying the solution, that there is going to be a little more volatility than you would experience in a traditional data center, and being able to account for that, building in the resilience to account for that. Back to Brian.
Thank you, Sanket. And I didn't know you guys were using Cloud Optimizer, so cool. All right, so double plug for those guys. Okay, so I promised a little bit of showing you how this all looks or runs, if you will, in the RightScale dashboard. So what you see here is, again, very washed out, so hopefully I'll highlight some of these things. But you see that in the deployment usage section, just to point out that, yes, this is indeed running in 2 different regions. We'll talk a little bit about which piece is where. We're doing a multi-region warm DR. I don't think I have it highlighted in this one, but the DB master and the DB slave you see there are both running in US East in different availability zones, as we generally recommend. What you see here is this DR DB slave. That's our disaster recovery database slave, which is running in US West and replicating from that master using Cloud Optimizer, so it's optimized and secure and all our other fun stuff. We then have these stage servers, right? We have these servers that are disaster recovery servers that are ready to step up and take the load if we need to, right? So if something catastrophic happens in US East, what do? Well, we promote that slave, that disaster recovery slave, we promote that slave to master, right? Once he's up and running, we go ahead and we launch those two servers with basically the click of a button, no manual configuration, right? Wait till they get up and running. This one doesn't have load balancers. If it did, the same concept, you launch those load balancers. Once everybody's up and running and everybody's been stitched together, you go ahead and you switch your DNS records and you point them from US East to US West, and you're up and running, right? So it really is that easy, okay? And we've done some of our own sort of test scenarios, and if you're expecting it, and that's not a little bit cheating because you're never expecting it, right? You can get yourself up and running in less than an hour, right? Depending on the size of your database and all that kind of stuff. But it's a very viable solution. A little bit of, actually I think I have another slide with even better, but we'll talk a little bit about cost forecasting and plan for cloud, which I think is next. No, we'll get to that in a minute. A little bit about automating and what we recommend here for HA and DR, right? Use dynamic DNS for those database servers. The way that the RightScale platform works, for those of you who aren't familiar, when you launch a master MySQL or Postgres server, for example, what it does is it uses a dynamic DNS record. It basically goes ahead and registers itself with some domain. It can be your domain or some dummy throwaway domain, right? It could be masterdb.dummydomain.com. And it goes ahead and it puts its private IP into there, right? So that when the application servers need to find their master, they do a DNS resolve on whatever I just said, masterdb.dummydomain.com or whatever. They get that private IP back, and that's what they use to connect, right? So you're not exposing anything. You're exposing only a private IP of, like I said, if you use a dummy domain, nobody even knows what it is, right? The point being that that IP that's exposed out there in DNS means no one to anything except your app servers, which it means the world to, because they can now contact their master, and if you've used security groups correctly, they're the only ones that can contact your master, right? You want to use a low TTL on those records. We generally recommend 60 seconds. So that if you do need to do a promotion, that's basically the downtime that you have, right? When you promote that slave basically takes over that record. He inserts his IP address in that record, and the app servers eventually, 60 seconds or less, whatever the TTL is, find that and now start connecting up to the new master, okay? You want to automate the connection of your app servers to your load balancers. Anybody that's using the RightScale tool set knows that we've already got that all built in, right? You basically want to launch these things. They're going to go ahead and connect up. If you happen to need to launch a new load balancer, he'll say, hey, who's down there that wants to connect to me, right? We've got all that automation in place for you. You don't want to do, obviously, no manual intervention. I mentioned this in the deployment checkup presentation earlier. If you're SSHing into your servers and dinking around at all, you should look at that. You should not be doing that, right? You really should not need to do that in production. Maybe in development and staging if you want to see what's going on, but you really should not be SSHing into your servers. Everything should be done in an automated fashion. And you don't need any DNS modifications here, right? You don't want to have to mess with that. Let the servers discover themselves using the RightScale tagging method and all that other kind of stuff. We always recommend the automated promotion of slave to master. We say here, process is automated, but the decision to run the process is manual, okay? A lot of folks, many folks have asked us, hey, you've got this cool, slave, promote slave to master. Why don't we just automate that? And if the master is down, I'm just going to go ahead and run, have that automated. We don't like to do that, and we won't do that for customers. And the reason is that there's just too many ways for a database to fail. And we always recommend that if your database is failing, hopefully you've got monitoring alerts set up to let you know that it's failing. Log in, see what's going on, see if it really is a problem with the database and not some other problem. The last thing you want to do is promote a slave to master when the master was fine and it was something else that was the problem. The example that I give, and this was about pushing it back maybe 3.5, almost 4 years ago now, we had a customer who we advised against them doing this, but they said, nope, this is what I want to do. I want to go ahead and take your guys' promotion stuff and automate it. And if the master is down, I'm going to go ahead and promote. And I forget the exact metrics that they used, excuse me. But what happened is that they had an application server that hit a bug in their code and got stuck in an infinite loop and was scribbling frantically to the master. So the master got stuck in this huge I/O wait state, and their metrics said master is down. So they went in, they promoted their slave to master, and what do you think happened? That application server went over here and started scribbling frantically to this one, and now they were in a bad way, right? So again, make sure it's an automated process. I can do it with the click of a button, but make sure you click the button and there's not some virtual monkey or robot clicking the button for you. How RightScale makes it possible. We touched on this a little bit, right? The multi-cloud image concept, right? We have the right images that run on every single one of our supported clouds and the regions, right? So we've got ones that run on AWS US East, US West, we've got Rackspace Dallas, Rackspace Chicago, we've got OpenStack, we've got CloudStack, et cetera, et cetera. Those right images implement the same version of the OS, right? CentOS, Ubuntu, whatever it may be, Windows. If you were to log into that server and do a PS and an LS, regardless of which one you logged into, they look the same, right? They're binarily, if that's a word, different, but they're going to look functionally the same, right? Those right images are under this multi-cloud image umbrella, if you will. There's a multi-cloud image that has a right image for all the supported clouds. And if you launch a template and point it to a particular cloud, we'll take care of figuring out which image you need and go ahead and hook you up over there, right? So we've sort of gotten that image management stuff handled for you, so you don't need to worry about it. Templates, tags, and inputs. This is just a few examples here, but we talked a little bit about automated load balancer registration and the database connections, right, using either dynamic DNS or the tagging system. Auto-scaling across zones, right, we've got that built into the platform. You can choose to use it or not use it. We always recommend that you do use it and spread those servers across the multiple availability zones. And then obviously do things all via dynamic configuration. You want this server to boot up and configure itself. And what you see on the left is just sort of an example of the boot script, some recipes that are part of the boot sequence for a particular server. And then a set of inputs over there on the right, which allow you to configure these servers. Anybody that's booted a server through the RightScale platform is probably familiar with both of these, right? The stuff on the right are the inputs that get fed into the stuff that runs on the left when you boot that particular server, okay? Here's the plug for Plan for Cloud that I mentioned. So I'm not going to go into the details of this, but if you want, you can go ahead and take a look at our Plan for Cloud tool. And Hassan, or maybe Kim, I'm not sure who did this, but basically plugged in some of our DR scenarios, if you will, into that tool and ran it for a very simple case. This was 3 load balancers, 6 app servers, 1 master, 1 slave, right? And said, okay, if I was going to go ahead and set up my warm DR and my hot DR, what would be the price comparison, stuff like that. You can go ahead and do Plan for Cloud and configure any sort of environment that you want, right? And I believe, and Kim, are you? Yeah, Kim, can you, I think with Plan for Cloud now, you can import an existing deployment. Is that true? Perfect. So if you guys have a deployment, you want to say, hey, I want to cost forecast this. I want to see how much this is going to cost me over the next 3 years. Or I want to see how much can I save if I use reserved instances, right? You can take your existing RightScale deployment, import it into Plan for Cloud for free, run that cost comparison, and figure out where those break-even points may be for yourself. So just kind of the last slide before we get into sort of the summary and questions is best practices, right? Just kind of beat the same horse over and over again. Place stuff in multiple availability zones, right? Make sure that every tier is spread everywhere, right? If you can, and I didn't mention this before, this bullet point here at the bottom, maintain capacity to absorb zone or region. We talk about zone in particular. For anybody who's familiar with how Netflix does things, not that they do everything perfect, but they have one thing that they do that I think is very cool. They intentionally over-provision, right? They're running in 3 availability zones of US East. I don't know why they don't use 5, but they use 3. That's their magic number. They have enough capacity so that if a particular zone goes down, the other 2 zones can handle everything, right? Which means that all of their servers are underutilized by intent, right? And the point there is that if they lose a zone, they don't need to launch anything else, at least not in a hurry. They want to launch some other servers to give themselves some excess capacity, but they can handle their immediate load if they lose a particular AZ. Now, is that a recommended best practice? Yes. Is that a recommended best financial practice? Probably not, right? You're spending a lot of extra, but again, it's always a trade-off. How much are you willing to spend? We talked about replication and failover, right? Replicate data across zones and back up your data across regions or across clouds. Use the monitoring and use that alerting. Find little problems before they become the big problems, all right? And then in your application design, same thing with the data. Make sure you push it around, right? And if possible, you want to have stateless applications so that if a server goes away, an app server goes away, no one knows, right? If you have sticky sessions pointing to a particular app server and an app server goes away, your users are going to know, right? The folks that are connected up to that are going to know. Not always possible, but again, if possible, try to design these stateless applications. And we'll just leave up some resources here before we get to the question slide. We have a bunch of white papers that talk on this topic and the hybrid IT topic and a bunch of other stuff at the link you see there. The first link in the webinars is sort of our generic webinars link where there's a bunch of webinars. The one that I think might be most pertinent to this group is the second link that I put there, but there's a whole bunch of other ones there. And then obviously Sanket's contact info, and they're looking for folks over there, so feel free to hit him up. That's all we got for today. We've got 10 minutes for questions. If anybody has anything, I'd be glad to answer, myself and Sanket, anything you may have. Anybody? Yep. Oh, we got our, hold on, we got our, it's late on Friday, late on the last day.
In your disaster recovery deployment you had up there, I took note that you're actually running both regions in one deployment, and I've worked with some companies where we do like a U.S. East deployment and then a HR U.S. West deployment. Do you actually find that that works, or is that just an example?
This is an example that I was able to fit on one screen, so it's a very good catch. Yeah, so generally, sorry, I talked about this morning, is that we generally also talk to, it's a great point, we talk to customers about using deployments as application containers, right? Put your entire deployment in this one, sorry, put your entire application in this one deployment. And I would suggest doing the same thing with your disaster recovery one. For the points of this discussion, I can lapse them into this one, but exactly, so that's a very, very good catch.
Yeah,
Anybody else?
We run separate deployments in both regions.
Yep, and that would definitely be the recommended best practice, so thank you. Anybody else? No? Cool. All right, well, thank you all very much for your time. Appreciate it.
Again, don't forget, please fill out the evaluation